Well, I don't want the red. Alright, and then if I came over here, from here to here, well, okay, we're from this point on, it is bounded between the two. But then after that, then it's up here. So if it's asking for this shaded region in the blue, what we have to do, it's easier to think about it horizontally instead, or I guess with the y values instead. So when you think about where they're bounded, you're just going to look at where they intersect again. So you're going to find where they intersect here, and you're going to find where they intersect here. And we're going to look at between this line and this line. So before we're looking at the x values, in between the x values, now we're looking in between the y values. And so if we're looking at the y values, then that means we have to use the y values, which means these functions have to be in terms of y. Whereas
So
here, like this is in terms of x, this is in terms of y. So we have to rewrite both of them. All right, so the notation, when you look at this one, is a little bit different. All right, and so instead of top minus bottom, you're going to do right minus left. All right, and it's going to be in terms of y, so it would be dy instead of dx. And for the integral, you're using the y value, so it's going to be y1 and y2. So top minus bottom, right minus left. So when we talk about area between two curves, that's what we're going to do. And then when we get into volume next week, the same thing applies. Right minus left, top minus bottom. It's just that one we're thinking about a 3D shape, so we're going to talk about like rotating it.
Whoa.
All right, so in this case, right minus left, if you're talking about it in terms of y. So in this case, we need to find those intersection points. So if I was just given the function of each of them, like what I have up here, how would I find where they intersect each other at?
Do you first switch it in terms of
So in this case, it doesn't necessarily matter which way you write it. Some ways are easier to solve than others, but it doesn't necessarily matter which way you write it in this case. So you can either use this function down here in the blue with this one, or you can go another route. Doesn't really matter how you do it. So you just tell me which way you want to go.
Well, I was going to switch them in terms of y instead of equal.
Okay, let's do that. All right, so if I switch this one in terms of y, what are we going to have?
Plus 5.
So this would be y plus 5 equals x. Let's see if that will go away. Yeah. All right, so we're going to use that function. So I'm going to write that here. And so if I was going to write this one in terms of y, so if we say in terms of y, are we good that that means solve it for x?
Yeah.
All right.
Yeah.
So in this case, I want to solve this one for x.
So it would be y.
So I would add the 2
divide by
and then divide by 2. So in this case, you would have 1/2 y squared
2
plus 1 equals x. So
Why'd
these
you
will be
keep
your
this
two
way?
functions. And so then you're going to set them equal to each other. So if I set them equal to each other, you're going to have y plus 5 equals 1/2 y squared plus 1. And again, what kind of function are we dealing with?
Quadratic.
Quadratic. So we're going to put it all on one side. All right, we can get rid of that fraction if you want to. You want to get rid of that fraction?
Yes.
I do too. So we're going to multiply by
2.
2. Let's just multiply everything by 2. All right, so we got 2y plus 10 equals y squared plus 2. All right, now let's get everything on one side. So if we get everything on one side, I'm going to have 0 equals y squared minus 2y minus 8. And so now again, it's a nicer problem. All right. So if I can factor this, and so what will that factor into?
Minus 2, or minus 4 and 2.
Y minus 4, y plus 2,
Yep.
which means that y is going to equal 4, and y is going to equal negative 2. And if we look graphically here, this point, I'm going to get rid of this, since it shifted on me. Okay, it's going to be this point would be at -2 when y is -2. This is the point when y equals 4. And so again, we're trying to find this area here.
Oh, 'cause it's all horizontal. Yeah.
And so in this case, since it's horizontal, we're going to do right minus left. Do we understand why it's right minus left as opposed to left minus right? I mean, yeah, I mean, if you think about, let's just do this. If I asked you, like, what's the distance
Oh yeah.
between those two?
Yeah.
You would do 5 minus 1. So that's the easiest way I can think about it.
Yeah.
Alright, so right minus left. That's what you're going to go with. So in this case, our right function, so if I write my integral, it's going to go from -2 to 4. And so the function on the right is going to be
Wait, which one?
It's-
Y.
the line, so the y plus 5. So that's the one on the right. And I'm going to subtract the one on the left. And the one on the left,
The ugly one.
we wrote it in terms of y here. So that's going to be subtract,
2y squared plus 2.
hold on.
No.
Oh, I just multiplied all by 2, sorry. 1/2 y squared plus 1.
Oh, okay, gotcha. Alright, and then that's gonna be, dy. And then again, algebraically, we could just take the integral here, like we can combine these two together, like we said before. You know, we can have -1/2 y squared plus y plus 4. And you could integrate that piece. So if we integrate that, you got -1/2 y squared. What would that integrate to be? What's the antiderivative?
Well, negative 1/2 y squared.
Yeah.
Would be negative 1/6 y cubed.
-1/6, because yeah, it's gonna be a cube, so then it has to be a third, so -1/6, y to the third. Alright, the y is a little bit easier. 1/2 y squared. 4 is even easier. 4y. And you're evaluating it from -2 to 4. So again, using this notation. And then again, just plugging in 4, plugging in -2. So you would plug in your f of 4 minus f of -2. And somebody either has a calculator or whatever, just like, what does that equal?
Zoom up.
Fingers.
I need Lucy here to complain about how to use the calculator.
She can do the math in her head faster than I can do it.
Yeah. She's
Lucy,
flashing fingers.
What are you
Just
doing?
swimming.
I don't know.
There's something you're like.
Wait, she had first wrong me.
I think you like put in. I don't know, there's something you're doing that they can take away.
We can do it for.
Or how do you do it?
I always just do parentheses and divide. Instead of
Yeah, this is
subtracting.
good enough. It's enough recording for one day.